All right, here's our topic 8 review. We are starting at number 1 as usual, and it says, what is BC? And I can see here I've got a right triangle, and I know 2 of the sides, so I'm going to be looking for this unknown side, which is BC. This is the side opposite of angle A, so I'm going to call it side A. And I can use the Pythagorean theorem for a squared plus b squared equals c squared. C squared is always going to be my longest side, and my longest side is always going to be opposite the right angle. So this is going to give me my 37 here. And since it doesn't matter the order in which I add, if I didn't have ABC as my triangle's vertices, and I had, DEF, I would just know that the 2 shortest sides go on the left-hand side. It's going to give me a squared plus 12 squared. And then I'm going to do just the basic algebra that follows from that. Now, 37 times 37 is how I'm going to find 37 squared. Definitely don't know that one off the top of my head, but it is 1369. Subtract 144 from both sides. And that leaves me with 1225. That ends in a 5, and I had 37 as my longest side. 12 is a good distance away. I know this has to end in a 5, so I'm going to assume my answer is 35. But to check that, I'm going to put in my calculator, and I'm going to hit the square root button, and it is in fact 35. All right, number 2 says, do the line segments with the given lengths form a right triangle? Here again, I'm going to need the Pythagorean theorem. And what I'm going to do before I start this problem is I'm going to make sure that my 2 shortest sides for each of these is on the left-hand side, and it is. So this is just going to be A, B, and C as I plug in. Now, since this is one that I don't need to write out, since they've given me all 3 sides, and I'm just verifying, what I'm going to do is in my calculator, I'm going to find C squared first, and then I'm going to minus A squared, and I'm going to minus B squared. And that should give me 0, because we know the Pythagorean theorem says A squared plus B squared equals C squared. So if these are equal and I subtract A squared and B squared from both sides, this is going to leave me with 0 equals C squared minus A squared minus B squared. So I'm just going to see if putting these into the calculator results in 0. So for the first one, I'm going to put 53, hit my squared button, and I'll write this one out just so you guys can see it. For this one, I have C squared being 2809. Now I'm going to subtract 45 squared. And I'm going to subtract 28 squared. And that does give me an answer of 0. So this does in fact form a right triangle. For the next 2, I'm just going to talk you through the steps of what I'm doing in the calculator. I've punched in 64. I'm hitting my squared button. Remember, when I say squared, it's going to get larger. This is x squared. This is the square root of x. A lot of times I see students mixing these 2 up on the calculator when I'm walking around. So be careful. When I say x squared, I am talking about making it larger. Taking the square root is making it smaller. So I have 64 squared. That's 4,096. I'm going to subtract 56 squared. I have 960 on the display on my calculator after doing that. And I have 33 here. Well, I know 33 times 33 has to end in a 9. And since I have 960 on the display, this isn't going to work out. But let's see what it does end up being just so you can verify it. So minus 33, hit the squared button, and then hit equals. And now I'm at negative 129. So this is not at all a right triangle. 0 does not equal negative 129. For my last one, 85 squared, 7225 minus 77 squared, hit equals. I have 1296 left on my display. There's a good chance this one will work because 6 times 6 will be 36. So minus 36 squared, and that gives me back 0. So this is our best way to do this, and it's the most efficient way to do it. Just take the number that is the largest, square it, subtract the medium-sized number, squared, and then subtract the smallest number, squared. All right, so number 3, the hypotenuse of a 30, 60, 90 triangle has a length of 15 centimeters, which could be the length of a leg of the triangle. Select all that apply. So my hypotenuse has a length of 15. So I'm going to go ahead and put that there. Here's my right angle. This is 15. So now I have to remember that thing I told you, or the thing I said, if we just do this, opposite of 30 degrees is just our side S. That is our standard side. That is our smallest side, and that's why we're going to use S for smallest. The opposite of 60 is just S times the square root of 3. And the side opposite of 90 is just 2 times my shortest side. So right now, I know opposite of 90 is 15, so I can say that's just equal to 2s. Oh, how about the 2? And I can solve for s by dividing both sides by 2, and this gives me 7.5 equals s. So I'm going to come in here, and I'm just going to put my 7.5 there. This is 15. And then to find 60 is really easy. I just take s, which is 7.5, times the square root of 3, and now I have all 3 side lengths. This is why I was telling you guys that 45, 45, 90 and the 30, 60, 90 are really good triangles to memorize the given rules for here, because you'll be able to do so much with these, especially later on as you get further into your math classes. Now, it says select all that apply, and which could be the length of the leg. So I am looking for 15, which never mind because that's the answer. I'm looking for 7.5, and I'm looking for 7.5 times the square root of 3, because those are the 3 answers that I had fall out from that little trick I told you to memorize the relationship of the sides. All right, number 4 is that classic geometry problem. This is kind of a entry step into your SAT prep for this class. It wants to know, what is the area of the rectangle? So we've got a lot going on here that we need to know about. First, to find the area of a rectangle, I'm going to write this as area of rec for a rectangle. That's just equal to length times width. Now, length is always the longer side, and we don't know what that is because we don't know what this is. And our width is 87. So in this case, the area of the rectangle is going to be equal to x plus 140 times 87. Now, it's not like we have to do anything else here that's too hard. We're not going to distribute anything. We can solve for x by using the Pythagorean theorem because we know it's a rectangle. And from topic 6, we know that this has a 90-degree angle at every vertex. And we have here now, this would be C. I'm going to call this A. And let's change this to B. And then we can just see here that this would be B plus 140. Just to keep it in terms of geometry, it doesn't matter which variable we use. And I really want you guys to start getting away from x always being your variable, even if we only have a few months left together. So for this one, I'm going to have 145 squared is equal to 87 squared plus b squared. And I'm going to punch that in the calculator because these are all perfect squares that I don't know. 87 squared is going to give me 7569 plus b squared. And all I can tell you right now about 145 squared is that's going to end in a 5. That's going to be 21,025. I'm going to subtract 7569 from both sides. And that leaves me with b squared is equal to 13,456. And to solve for that, I'm going to take the square roots of both sides. And again, when I take the square root of something, I get plus or minus. But since we're talking about length, I'm going to just move into that. And right now I know b equals 1/16. So if I come back into here where I've set up for the area of the rectangle, I have now, through substitution, 116 plus 140 times 87. That's going to give me my area of the rectangle. And that is just going to be 256 times 87. And that leaves me with an answer of 22272. All right, no calculator needed for this one, just some quick reasoning. And if we stick with my trick that I showed you in class to make sure we always pick the opposite and adjacent correctly, it's going to be a pretty easy one. So it wants the sine ratio of angle A. So before I do anything, I know what my reference angle is, so I'm going to identify everything I know about it. I go straight across, even though this is a highly exaggerated one, right? This is the side straight across. So that means 195 is my opposite. So I'm going to leave a note underneath it as the opposite of A. Now, a lot of you know that sine needs opposite over hypotenuse, and you can already move on. But there's a good chance, obviously not in this question, but in normal, we're going to need to reference some other stuff. So what I always do, and I'm just going to put it in the video again, is I find the side opposite of my reference angle, and then I identify the hypotenuse. Because if I do those two things, well, I know the hypotenuse is always opposite the right angle, and finding the side opposite of the angle is easy. If I have those two pieces of information, all that's left is that adjacent side. I know sometimes students will see something highly exaggerated like this and feel like if they go straight across, they're going to hit this 28. So I like to just be extremely careful when I do this, and I follow this step every time. Now I know I need the side opposite over the hypotenuse. This is going to give me 195 over 197. And this one wouldn't have been too bad if we actually, if we were taking good test taking strategies and look at our options first. I don't do that on these videos because I want to make sure the answer I give up is the one I arrive at naturally, and I'm not relying on multiple choice. But let's look at this really quick before we move on. We know the hypotenuse is 197. And there's only two choices where I have a hypotenuse over, or the hypotenuse in my denominator. What they're doing here is exactly what I was saying, why I'm always careful with something so exaggerated as this. Sometimes it'll feel like, as you're coming for opposite, you may see this, test A nerves, and you pick it. So this is actually the cosine of A. This is the sine of A. 195 over 20. This is the tangent of A. And I can put all those together so quickly because, like I say in class every time, always identify the opposite side from your reference angle and the hypotenuse, so you know all three pieces of information just in case something comes up. 28 over 195 is the tangent of B. So again, it's good to know all these things, but be careful on test day. Double check, verify, see if you come up with any questions. Start doing that process of elimination. It'll help you out immensely. All right, number 6, pretty straightforward. It just wants to know which of these A through F trig functions with their argument, and when I say argument, I mean the angle that I would punch into the calculator, put in the parentheses when I write it out, equals 1/2. A couple things I want to do. I know on the calculator, it's not going to show me 1/2. It's going to show me 0.5, and I get that by dividing 1 divided by 2. So I'm going to see how many times, or for any of these, what do I get? To do this, if I'm using the TI-30XA, which is really the one we should all be using, because that's the only one you're going to be able to use during the EOC, and if we're comfortable with it now, we'll be comfortable with it on test day, and you have a chance to ask me any questions. I'm going to put the directions for writing each of these, or punching each of these into your calculator. So for A, put it over here. I'm going to punch in 30. And then I'm going to hit the sine button. And that does give me 0.5. So this one is good to go. For the next one, it is the sine of 45. Now, I already know 30 sine, or sine of 30, sorry, or 30 sine if I'm punching in the calculator, is 1/2. I'm going to tell you right now, there's no way the sine of 45 is 1/2. And it definitely is not. It's 0.707106781. So that is a no-go. So once I know sine, which value of sine gives me 1/2, all the other signs can be instantly ruled out. Once I know which value of cosine gives me 1/2, it's instantly ruled out. Now I happen to know more than, I have extra background information, so I know that D is going to be right. But we're going to show you how to get each one in like I promised. So let's do that. So the cosine of 45 means I'm going to press 45 and then hit cosine. And then does that equal 0.5? Double check just because we don't want to turn out any bad information. No, it does not. This actually doesn't even come close. It's that 0.707106781 again. That seems to come up a lot, doesn't it? Wait till you find out why. If I go here for 60 cosine, or the cosine of 60, I do get 0.5. For E, it wants to know what is the tangent of 30. So I'm going to put 30. Hit that tan button. Remember, anything in the box is an actual button you're going to press on the calculator. But that does not equal 1/2. That is something like 0.577. We need exactly 1/2. Just because we have that 0.5 up front doesn't mean we have it. And then for the last one, we have the tangent of 45. So I'm going to hit 45 first and then hit tangent. And that is actually 1 and not 1/2. So there's only 2 right answers with 6 options here. So be careful on test day that you verify every one of these. This is why I gave you that chart. Every one of those answers, the very first thing we did when we started topic 8 was copy down that chart. Every one of these answers is on there ready for you. So you didn't even need the calculator if you're using the chart. All right, guys, let's knock out number 7. It's not going to be too bad. If you look at that chart we were just talking about in the previous problems, we're going to have a really good shortcut on this one if we're using the law of sines, right? I know that, law of cosines would be just as an acceptable way to do this. But for the law of sines, I'm going to do my template where I set up the sine of something over something is equal to the sine of something else over something else. And if I do that, if I look at my known angle with its opposite side pairing, it's going to give me the sine of 90 over 5. And this sine of 90 is something special. If you look at, oh, you know what? The sine of 90 is not on your chart. So put that in your calculator and look at how nice of a number that is and how easy this is going to be when we set this up. And this is why I use that template. Here's that an additional insight as to why I think this is such a valuable way to always approach these problems. And that is this. If I want to know any of the other parts here, I'm looking for the perimeter, which, sorry, I didn't jump right in by reading the question. I was, I guess, too excited, so I wanted to talk about why I'm choosing the law of sines here. If I want a, little a here, it's going to be the sine of 61 over a. Now, if you didn't punch in the sine of 90 into your calculator yet, sine of 90, it's just equal to 1. And what's really nice here, it's when I cross multiply, I'm going to end up with the sine of 90 times a. So let's say a sine 90. It's equal to 5 times sine 61. And what happens here is I just end up with 1 times a is equal to 5 sine 61. And that just tells me straightforward that 5 times sine of 61 is equal to A. And I don't have to do any other steps. I don't have to divide, and I have to worry about making an order of operations mistake or anything as far as the division goes. And I can just plug in 5 times sine of 61. And as soon as I get that answer, I don't have to do anything else. So when I do that, I get little a is equal to 4 and it asked me to round to the nearest tenth. So I'm going to write out to the hundredths. 4.37. Now, without showing you all of the steps again, I'm going to show you how much nicer this becomes. Here, if I want to know little b, do that one in red, and I'll do it down here. I'm going to have the sine of 90 again over 5. Again, another nice thing, our left-hand side is always going to be the same if you use this approach I showed you. And then for b, it's going to be the sine of 29 over little b. Up here, I've already shown you that this is going to become 1, and I'm just going to end up with a equals on this side. So this is just going to be b times 1, or b is equal to 5 times sine of 29. And I punch that into the calculator, and I get 2.42. For the perimeter, I just want to add all of my sides up, so I'll do that over here. It's going to be 5 plus 2.4 because I'm rounding to the nearest tenth. This tells me to keep it the same. However, this one tells me to bump it up to 4.4. Right now I have 9.4. And when I add this, I get 11.8. And that is my answer. So going with this, if I know the right angle and its opposite side, that sine of 90 is always going to turn into a 1. And when I cross multiply using the template I told you to set it up with every time and always practice, you're going to instantly solve for the variable in one step when you cross multiply. And that's a really nice outcome. And it makes things so much cleaner at the end. Number 8 wants to know what is the measure of angle A. So I'm going to go ahead and put that up as my reference angle to the nearest tenth. That's at the end. I'm going to round for that. So I'm looking at A, and I want to know what information do I know and not know about it. And we're always going to follow those same steps. The first thing I'm going to do is identify the side opposite of A. I'm going to write a little note here that this arrow is pointing at the side opposite of A. Then I want to identify the hypotenuse, because once I know those two pieces of information, the remaining side that I haven't done anything with yet is always going to be the adjacent side. If you guys are going to make any mistakes while you're learning this and you're getting the hang of it, sometimes you will confuse your opposite with your adjacent, especially if you don't leave yourself a little note like here. That's my reference angle. So I want to make sure the reason I'm finding this is because I'm finding the opposite of my reference angle. I want the adjacent of my reference angle. Obviously, on any of the right triangles, the hypotenuse is going to be the same. If we're not looking at any reference angle, it's still the hypotenuse. So, and then this side is going to be adjacent. So from my reference A, I happen to know I have numbers, or I have values for the opposite, and I have values for the adjacent. So I need to know which trig function do I use. And if I think about it, it is tangent is equal to the opposite over the adjacent. So I'm going to put the tangent of A is equal to the side opposite over the side adjacent. And now I can see I have my variable is in my reference angle. Well, how do I get my reference angle out? How do I solve for just A? By taking the inverse of my trig function. So now all I have to do is punch these two numbers, punch this expression actually into the calculator, and then press second tan, and I'll get the measure of angle A. So I have 22.9. And of course, these directions I'm giving out verbally are for the TI-30XA. If you're using the TI-30X2S, you're just going to punch it in exactly like you see it. So let me start over. I have 22.9 on my screen. I verified I'm in degrees. I'm hitting divide by 14.1. I hit equals and I get 1.624113475 on my calculator. And now I see that I want the inverse tangent because I'm solving for an angle. And I get 58 when I hit second tan. 58, well, that's a little bit of number mix up there. 58.3, not 53.87. 8. Ooh, we're just going to stop there. 58.378. And what it wants me to do is round to the nearest tenth. So I'm going to look at my tenths value. That number is greater than 5, so I'm going to end up with 58.4 for my answer. All right, we are skipping number 9. It's just a vocabulary question, and we'll do vocab later on. So right here it says find the value of x to the nearest tenth. So I'm going to look at what I have. Well, I have an angle and its opposite side that are known, and I have an angle and an unknown side. This tells me right away, go with the law of sines. So let's write out my template. Sine of something over something is equal to the sine of something else over something else. And remember, on my left-hand side, I'm going to put the angle and its opposite side that I do know every time. It's going to give me the sine of 33 over 59.2. And then on this one, it's going to be my one known and my one unknown. My unknown is a side. Sides always go in the denominator. And then my known angle for this relationship goes there. This is going to end up giving me x times the sine of 33. That's going to be equal to 59.2 times the sine of 73. I want to isolate my x, so I'm going to divide by sine of 33. And these will obviously cancel, leaving me with x is equal to 59.2 times the sine of 33, 73. I need to thicken this pen so I can see a little better. Over the sine of 33. And then punch this into my TI-30XA. I'm going to punch in 73 sine times 59.2. And now that I've done everything in my numerator, let me say it again so you can see it as I'm punching it in. I'm going to hit 73 sine times 59.2. I hit equals, and right now I have 56.61324,155 over, or now I'm going to divide by, because that's this bar right here, 33 sine. And I hit equals, and I get 103.94. It says it's to the nearest tenth. Let me actually write it out so we can see it. This is going to be equal to 103.94. This 4 tells me to keep the 9, so I'm going to have a final answer of 103.9. For number 11, I'm going to delete it off of your test on Savas, but I will share my screen and you will have another problem similar to this, but I want you to write it the way that I would have you write it in class. The sine of something over something equals the sine of something else over something else, because what they want is for you to set it up and find all of that. They want it in like one compact, fully written out, fully cross multiplied, one expression. But if you can get to that point, then you've done the whole problem. I just want to see if you can set it up. And for this one, to set it up, what we're going to want to do is identify what angle do we know and what side opposite of that known angle do we know. That's going to be these two. So I'm going to have the sine of 73 over 26.9 is equal to the sine of x over 15.5. There's one last step I have here. I am looking for an angle, so I want to make sure I include this right here, right? Because once I solve for all of this, I'm going to want that inverse sine to pull out that x and tell me what angle that is. So on the day of the test, while we're in Zoom, you're just going to send me a private message with exactly that right there. But yeah, because you guys can upload files. So what I'll have you do is just direct message me your file so that I can see you know how to set it up. And then we can move on from there. And this will be a bonus question. All right. So let's do number 11, or that is 11. Let's do 12. So we want the perimeter this time to the nearest whole number. So let's knock that one out. We'll stick with that nice green. To do this, I see here again, I have the sine, using the law of sines, of 49 over 19.5 is equal to the sine of 40 over, well, C, right? Opposite side, the angle has the same name as the opposite side. So here I'm going to have C, that's a really bad C, times the sine of 49 when I cross multiply is equal to 19.5 times the sine of 40. If I divide both sides by the sine of 49, this will cancel, and I'll be left with C equals 19.5 times the sine of 40 over the sine of 49. If I plug that into my calculator, I have to punch in 40 sine times 19.5. It equals, and that gives me, I should have on my display right now, 12.534355839. And I'm going to hit divided by, because I've done everything in the numerator. Now I'm at my fraction bar. So divide by 49 sine, and then hit equals. And that tells me that the side opposite of 40 is 16.6. And I'm going to leave it there since we're going to the nearest whole number, and that will give me my rounding point. Now I need to find my side A, and we're going to change to a blue for that. So for A, I'm going to stay with the law of sines, so I know what my left-hand side is going to look like. I'm going to do it over here. The sine of 49 over 19.5. Remember, we can't use the sine of 40 over 16.6 because we rounded here. If we wanted to use that, we'd have to leave it as this right here. And that is a nightmare of calculator proportions. Not the best joke, but you definitely don't want to set yourself up, because there you have a higher chance of pressing the buttons wrong. So what I want to do here to solve for angle A is just do 180, because we know the inside of a triangle adds up to 180 minus 89. And that's just because it's 40 plus 49 gives me 89. And there I'm going to be left with 91. The way I did that was if I just plus 1 here, 180 minus 90 is 90, and then I add that 1 back, and I'm left with 91. All right. So now that I know A is 91, my right-hand side is going to be the sine of 91. Unfortunate that it's 91 and not 90, because then we would already know that's a 1 on top, over my unknown, or my little a. Let me erase this just so we can see. This was just solving for the inside of the triangle. Here's my little a, because it's opposite big A. So now I'm going to cross multiply. A times sine 49 is equal to 19.5 times sine 91. Divide both sides by 49. That leaves me with A equals 19.5 sine 91 over sine 49. Now look here on this side. Let me do some highlighting real quick. Here's my variable I'm solving for. Here's my variable I'm solving for. Here I have sine 49. Here I have sine 49. Here I have 19.5. Here I have 19.5. As you get more comfortable with these, and I've been fighting the urge to do this every time, if you follow my template, all you have to do each time is change the angle that you are looking at. What is your reference angle? On the right hand side will change. You'll see that's the only thing that changed besides the variable. And you can just do it that way, and it'll be a much more efficient process. So now let's put this in. I have 91 sine times 19.5. It equals, and I'm seeing 19.49703,006. I've done everything in my numerator, so I'm going to hit divided by 49 sine and equals, and I get 25.8. Let me change off of my highlighter. All of this is equal to 25.8. So I'll put that down here. And now I can just add 25.8. Oh, I'm sorry, 25.8. So 25.8 plus 16.6 plus 19.5 equals 61.9. And that's going to round to 62. So the perimeter is 62. All right, let's break this one down again. This is the law of cosines. This is going to be another extra credit question on this test for you, because the way they want and expect you to answer it is not something you're ever going to do. I'm going to break this down to one equation, and that's going to be x squared is equal to y squared plus z squared minus 2, and then I have b again. So that's going to be y. Then I have c again, that's z. I can't move that over. Sorry. And then cosine, and since a was replaced with x, we have cosine x. Now, I've just done that because I can do this for any of the variables. If I had started with the second line, I could have said b was x, a was y, c was z, and we'd get the same formula. So right now we just took 3 different equations and we knocked it down to 1. That's just x squared is equal to y squared plus z squared minus 2yz times the cosine of x. So first off, that's easier to remember. Also, it's in alphabetical order now, whereas only the first line was on the left-hand side what was typed. Now I'm going to point out again, the reason I do this is everyone here, and I said it earlier in the video, we have to get away from this, but for something as complicated as this, these are the 2 variables we're trying to solve for. We're either going to be solving for little x or big X. Let's put a line underneath that. So these are my unknowns. And if I keep that in mind, this makes these types of problems exceedingly easy to do, at least the setup for them. And luckily, that's what we're being asked to do. The calculator might be a bit more complicated in these because there is a lot going on. Now, on everything between the equal sign up to cosine is what we know. All right, so now all I have to do is memorize one equation. And then as long as I understand that I'm solving for x, I'm either solving for the side length, that's the left-hand side, or I'm solving for the angle, that's the right-hand side, everything else will fall into place. All right, when I give you this problem, I'm going to tell you, I'm going to give you numbers, and you can just plug in the blanks there. All right. But what I want you to understand is, and we're going to do a whole we have already done a whole lesson on this. If you're watching this after the lesson, if you're watching this early, we have a whole lesson coming up on this. But we're going to turn these three equations into this one. As long as I understand either the one of the two outsides is what we're solving for. We're either solving for the unknown side, that's this one. Let's not use the same color that we said is known. So if I'm looking for a side length, I'm going to plug in, that's going to remain unknown. If I'm looking for an angle, this is my remaining unknown. Otherwise, once I set this up, I'm down to just one variable. All right. This one's forcing us, number 14, is forcing us to use the law of cosines. So I'm going to write that out as x squared is equal to y squared plus z squared minus 2yz cosine of x. Now I know I did this right because my two unknowns that I'm going to solve for are usually x. That's what we've been conditioned to the last 10 or 11 years in school when we're solving for an unknown. So those are on the outside. What it wants to know is what is BC, that's this one right here, to the nearest 10th. This is the side length, so this means this remains in my equation. Everything else is known. And I'll show you what I mean. I'm going to define this as side y, and this is side z. So now I'm going to have 26 squared plus 30 squared minus 2. And then I'm going to use these numbers in the same order. 2 times 26 times 30 times the cosine of x. And the cosine of x is 95. So that is the side opposite of it. And now I can start running all of this through my calculator to get an answer. This is going to give me x squared is equal to, it's going to be slightly over 625. It should be 51 more than that, but let's see what we have. 676 plus 900 minus 52. So now I'm going to do my minus 2 times 26, which is 52, times 30. I have 1560. I'm going to go ahead and write this out. I'm not using any ink to do that, so it's not being wasteful, but I want to make sure you see what we have here. Now I have to punch this in. No, I don't want to do that because cosine of 95 is irrational. I want to combine these two. Sorry. This is going to be 1576, 676 plus 900. That gives me 1576. Now here's where you're going to make your mistake. This is 1560 times something, so I can't do my subtraction yet. I have to know what this value is. So on my calculator, this is where I have to stop, and this is where the calculator has to take over because we've got this cosine of 95 in here, which is going to be irrational. So I have 1576 on my display, and I am doing minus 1560 times 95 cosine and hitting equal, and I get 1711.962959. But remember, even though we didn't carry it down the whole time, this is our x squared, so I'm going to take the square root of that. And I get x is equal to 41.37, which rounds to 41.4. All right, here's another one where we're forced to use the law of cosines. And that's because we don't have enough information on the inside of the triangle. We don't know what the angles are. So we have no way to set up the law of sines here. I have my right-hand side available. I could say x sine of x over 62, but I have nothing for the left-hand side. I don't have my other known angle in its opposite side. So I'm forced now to use the law of cosines. So let me write it out just so I can make sure. That I have it ready to use. And it wants to know what is x to the nearest degree. Well, x is equal to the measure of angle B. And I'm just going to keep that in mind because my unknown is an angle. That means this is going to be my unknown. So everything else needs to be filled in. Side x is opposite of the angle marked x, so that's going to be 62 squared is equal to, and I can pick either 78 or 44. I'm just going to do y here and z here. It's going to give me 78 squared plus 44 squared minus, and I'm going to put it in the same order, 2 times 78 times 44. And I'm going to make this one change. Since I know this is my unknown and I need to pull that x out, I'm going to do the inverse cosine, since that's what I'm solving for in the end. And I need to isolate that. So we're going to have a bit more to do in this one, because it always takes more to find the angle. But before we get into that, 62 squared is 3844. 78 squared is 6084. 44 squared is 1936. Then I have to subtract 2 times 78 times 44. So 2 times 78 times 44 becomes 6864. And that still times the inverse cosine of x. That is just a really bad parenthesis. All right. So now, this is the fun one. Are you ready? Well, you guys already know if you're already learning the lesson. I need to keep in mind the entire time I'm doing this, my order of operations, and I have to make all of these steps done properly. Here, there's nothing on the left-hand side to do right now. If I look here, I'm trying to slowly get to this to isolate it. So I want to combine like terms here to get this block ready to move. So 6084 plus 1936 is 8020. And that's positive, so I'm going to subtract 8020 from both sides. I forgot on this calculator. We'll just start over. So 3844 minus 8020 gives me negative 4176. Of course, this is now gone. Is equal to negative 6864 times cosine negative 1 of x. Now this is a number times a number, and if I want to undo that, I'm going to divide by one of those two numbers. So here, I'm going to divide both sides by negative 6864. And you do want them on the left hand and the right hand side to be negative or double positive. Not going to see double positive very often right now. This double negative is really going to be our fraction that we're solving for here. These will cancel, and I'm left with the inverse, or the arc cosine of x, is equal to negative 4176 over 6864. That's double negative, so I'm not going to worry about that when I put it in the calculator, because I know that's going to become positive. So I'm going to do 4176 divided by 6864. It equals, and I get a small number, 0.608391608. And since I want the angle, I'm going to hit second cosine, and this tells me that we have an angle of 52.526. And it says to the nearest tenth. That means this, looking at this too, 52.5 for my angle x. All right. And now, it would be difficult, but we could use the law of sines now that we know that inside angle. All right. Here's probably the most difficult question on the test. Not because, well, not for anything more than just the amount of time and reasoning it's going to take. Here, if I write out my law of cosines in the form that I have showed you, I can start looking at this. If I were to look for angle A, that means this would become cosine of A over here. Obviously inverse. Now, the problem is I also know, well, I do know this, right? But I don't have enough sides here. I still have no idea what z would be if I make this y. So for this one, I can't do it. Let's look at for angle B. Nice thing about writing this in general form is I can now change this to cosine of B. And we're going to quickly see, well, not even that. We already know what it is. So no, we don't need the law of cosines to solve for it. Now let's look at what's next. Angle C. Well, if I were to do that, I don't know what C is. I do know that we have 26 squared here, but I still don't have enough information with that missing side. So again, I can't do that. Now, do I have enough information to solve for AC? I really hope this is not an all no situation. Now that we're switching from angles to sides, let me clear this off just so we can see in its original form. Okay, looking for AC. I do have cosine of 39, so that's a good start. And then that means my unknown is going to be over here. So that works. Where's my pen? There we go. Now, I can make this one y and this one z, and I can see here, this has a substitution, this has a substitution, this has a substitution, and this has already been substituted, and I'm left with one variable, so I could, in fact, find side length AC. I'm trying to think of the best way to say to condense this down on test day where you can look at it and quickly analyze it, and I don't want to do it because I don't want you to overgeneralize or just say, oh, that worked in my mind and I haven't checked it, so I'm not going to do it. Just follow, the steps. Write out the formula and see if you can get it down to one unknown. Here, if I were to fill this out, I have y at 26. This would be 26 squared plus 17 squared minus 2 times 26 times 17. And there I can see I am now solving for x, which I have on here as AC. So that is the only one we can do with this available information. All right, now we've got our angle of depression question in number 17. And if you go back to your first day of notes, this is that one that I warned you was going to be the one that you're most likely going to make a mistake on as far as word problems go. I'm going to go ahead and draw this. It says, what is the angle of depression from the start of a 3-foot high ramp access that ends at a point 20 feet away along the ground? So I'm interpreting this as this right here. We have a ramp. This is where you would get onto it if you needed to use it. This is my direction of travel. And I'm worried about the direction of travel just because it's going to be important when I do this. So this is, what is the angle of depression from the start? This is why I'm worried about the angle or the direction that I'm traveling. From the start of a 3-foot high access ramp. So I want to make that note. I know it's 3 feet tall. Even if I have my direction wrong right now, we can go back and fix it. That ends at a point 20 feet away along the ground. No, this is definitely it, right? Only traveling in this direction does it make sense that you're starting at 3 feet high and you're 20 feet away when you land. So what it's asking is for the angle of depression. Now, is there a dotted line option? No. I'll put it in a different color. When it's asking for an angle of depression, it's basically asking us what is our angle that it's going from our eye level. And I put little air quotes on that even though you can't see me. But as I'm descending down this ramp, what is this constant angle? This is the same as our airplane extra credit, just upside down. And this is why I said it gets really confusing. But what I can do here is, like I showed you in class, a nice little workaround here is this also would make a 90-degree angle if this makes a 90-degree angle, right? So what I'm going to do is I'm actually going to solve for this angle and then just do 90 minus that. I'm going to call this, let's just call this one theta. Flare on that. So 90 minus theta will equal my angle of depression. And that's pretty easy to see. We've been doing geometry long enough. Topic 2 topic 1 actually really took us through that whole idea of if I have two parts of an angle and I know the whole angle, I can separate them and stuff. Tons of videos on that on the channel too if you want to go back and review it. So if I can find this angle, I can then just subtract it from 90. Now, the way I'm going to do that is I'm going to still follow my same steps that we've been doing since day 1. This is my reference angle. I want to identify the side opposite. And then I want to find the hypotenuse so I know what's left is adjacent. So this is opposite of theta. This is the hypotenuse. So that makes you, Mr. 3 feet, the adjacent. So now I can set this up knowing that the tangent of inverse theta, because I'm looking for an angle, is equal to the opposite over the adjacent. And I'm going to punch that in my calculator. So 20 divided by 3, and then hit second tan. And we have an angle of 81.46923. So don't jump right into this. And fortunately for us, Savas was nice enough to not give us this as one of our options, right? So we might feel like we got it wrong though, and that's not okay because we are right. So they're definitely doing some rounding here. It doesn't say to round, but this is going to give me roughly 81.5 since everything I'm seeing is in the tens place. Now, this is just theta. This guy right here is 81.5. That's not the angle of depression, right? We already know that the angle of depression is equal to 90. That's this 90-degree angle minus whatever theta is to get that. So let's do the math on that. I can substitute in here. I'm going to have 90 minus 81.5, and whatever that equals will be my angle of depression, and that is 8.5. So there's that extra step. Hopefully doing the slide project over and over again in class on Wednesday. Thursday I won't be there, so I'll do it in the video for you and you can try it out and follow along. But hopefully that helps with the angle of depression. Again, this is the angle of depression. How much are you going down the ramp versus, you know, the airplane problem and everything else we were doing at first was up the ramp. All right. Now we're just really deep into the word problem, so let's just keep drawing them out because there's no better way to approach a word problem in geometry than giving yourself something to work on. The angle of elevation from a viewer to the top of a flagpole. So we're going to have a person looking over at a flagpole, and this is going to be their line of sight, is 50 degrees. So that's good. They're giving us that already. So we have our person. Remember, all of this information is based off of their line of sight. One day I'll draw somebody whose arms are actually connected to their body. If the viewer is 20 feet away from the if the viewer is 20 feet away in reference to the flagpole, so that means here, and the viewer's eyes are 5 feet from the ground. Ooh, that's some nice little bit of, this is why we're drawing it out. Let me show you what that's saying. So obviously we're standing on the ground. And if you're viewing something, right, just missed it. Probably be smarter to go this way. Right? The flagpole doesn't begin existing when you look at it, even though some people might argue that it does based on their view of the world. But here we have your eyes are 5 feet off the ground. So this person's, you know, probably 5'4", 5'5". Let's make sure we're putting our units in because there's a lot of measurements going in here. This was feet as well. It wants to know how high is the flagpole. So this is important because when you're looking at this and you're using this 50-degree angle, This reference angle is generated from your eyes. This is why in class we did that thing where we said look straight ahead, then just moving your eyes, look up. That's where the 50 degrees is created from. Now that's important to know because if we were looking, let's just do this so you can kind of see it happen. Let's go orange. If we were to lay our head on the ground and then look up to try and measure, that would give me, as you can see, a very different angle. Maybe not very different, but it would be slightly different. It's going to be a greater angle, right? You have to move your eyes more from ground level than those 5 feet. So we have to account for that 5 feet when we're doing this. So the first thing I want to do is set this up and talk about why we're setting it up this way. Very evident what my reference angle is. It's going to be 50. So whatever trig function I decide I need based on the information I'm given, it's going to have that 50 inside the argument. Here's my hypotenuse. Here's my opposite of, let's just call it E for eyes, right? The angle generated by my eyes. So we'll put an E here. All right, so there's one extra thing we haven't really done too often, or we've done it in class and on the homework. We haven't done it on this test yet. And that is, once we solve for our height, we have to also consider this extra information. So when I set this up, knowing the opposite and the adjacent is going to give me the tangent of 50 degrees is equal to x over 20. And when then I'm going to solve for x, and then I got to add 5. So keep that in mind. So what I'll do then, just to show it mathematically, is this. And I'm going to solve for x first, and then I'm going to consider that. So inside the parentheses, since I have to do that work first, this is going to give me 20 times tangent of 50 is equal to x. And then I need to tack on that plus 5. So I'm going to go ahead and solve for x here, and that's going to give me 23.83 to the nearest 10th, yeah. Which means this is going to be 23.8 is equal to x. And then I need to add that 5. So this just becomes 23.8 plus 5 for a total height of 28.3. So our flagpole is 28.3. We have to add that 5 on to account for eye distance, the distance from our eyes back down to the ground. All right, this time we've got what is the angle of elevation to the nearest 10th of a degree to the top of a 45-foot tall building from 85 feet away. So here's our building. Find my straight line tool. We want to know what is the angle of elevation to this building. So I'm just going to draw and set it up that way. Now we know this building is 45 feet tall. And we're 85 feet away. So we want this. This is theta, and we're going in this direction. We're going from the ground and looking up towards it. So now this is similar to the last problem, but instead of counting from our eye height, maybe we have a survey marker and we're just looking through and getting our measurements that way. So this one's actually pretty easy. Start with our same steps we always do. Identify the opposite and the hypotenuse. Here's my theta, or my unknown angle. This building will meet the ground at 90 degrees. So this is our hypotenuse. This is our opposite of theta. And this is our adjacent to theta. So it looks like, again, we're going to be using tangent to solve for this. Now, not just any tangent, but the arc or inverse tangent, since I'm looking for an angle of elevation. Opposite, I have 45. Adjacent, I have 85. And I can just plug this into the calculator now and get my answer. This is going to be 45 divided by 85 equals second tan. And this tells me that theta is equal to 27.8972. And what does it want? To the nearest tenth. So 27.9 degrees is my answer. On the test, you're not going to have to put in degrees. but I just like to write it.